morning. Welcome to our webinar, Filleting Masterclass. Learn how to conquer fillets in SolidWorks. I'm Chloe, Application Consultant of CADVision Systems. You guys hear me? Alright, let's start our webinar today. It is all about fillet, how to make a good fillet in SolidWorks. If you have any question, you can raise your hand. Okay, and I will get back to your question later. So before we go ahead to the technique how to make a good fillet, let's have a look the concept of fillets. What actually behind it, the logic behind fillets. So fillets always need somewhere to end. Okay, look at this example, this picture. I would like to make a fillet for the edge in red color. Okay, so what we do next, then we apply a fillet for that. So you will notice that actually for SolidWorks fillet, okay, it is able to automatically extend the red color face so that the fillets has a place to end. Okay, you should always remember when we do a fillet, there must be a place or face to end it. So the red color face, you can see if you compare with the previous picture, the geometry a little bit different because it is automatically extended so that to fulfill the command that you key in for the fillet with that certain value. Okay. Same for this another example that if you wish to make a fillet in this way, the blue color, all right, the blue color region. So if let's say this is the case that if the fillet not able to extend face, right, it will be seeing something like this, which is invalid and that unable to do that. So that's why SolidWorks automatic extend the red face again, which is another red face to giving the fillet to have somewhere to end. Okay, so it's a totally two different concepts. Two different examples, but showing you the same thing. Fillets need somewhere to end. Okay. So if let's say you combine these two fillets, after we apply the red fillet and then we apply the blue fillet, you will see that if there is nowhere to end for the blue fillets, okay, then that's why SolidWorks it appears that the fillet it is tapered and then it becomes zero value, meaning the blue color fillet it becomes ending like this in a sharp corner, okay, because it has nowhere to end. Okay, right. So now you already understand how fillet works in SolidWorks. It is always need something to end. So in the next section, I'm going to show you some common fillets in SolidWorks that we always use it. So the first type of fillets that we have, constant size fillet that you can see on screen, which is very common. The fillet that we always use, the basic fillet. Okay. So the another type is actually quite a new features in SolidWorks, which is just released I think about 2 to 3 years ago. Conic fillets, which it is fillets that we control by using row value. If you compare the left hand picture, constant radius, and then you compare with the right hand picture, conic radius. So the difference is that constant radius having the same radius for the whole section. Okay, but then for conic fillet, it create a section that with hyperbola geometry. Okay, so this shape it is all controlled by the row value. Okay, so I'm going to show you how basically the row fillet works. Okay, this is a simple rectangular box. So I'm going to apply a fillet. So you can see on the screen, the fillet type we have constant size fillet, okay, variable size fillet, base fillet, full round fillet. The rest of the three I'm going to cover later. So the first one I will explain for the first one now. Constant size fillet. Okay, let me apply this stage. Maybe 1 inch. Okay, so for constant size fillet, this is the basic standard fillet, which is using a profile circular. Okay, that is exactly the same I explained just now, the constant size. Okay, if you see from side view, it is this way. Constant radius. Okay. So what if we changing to another type, which is conic fillets? Conic, which you can choose the profile and change it to conic row. Conic row and conic radius is the same. Row is controlled by the row value, and the radius is controlled by the radius value. So if I choose it conic row, and I can change the value of row. Okay, so the value is differentiate is like this. 0.5 is exactly the same like just now, constant radius. If you lower than 0.5, it becomes this way. Okay, you will notice that the profile is a little bit like flat base. It is very flat. Okay. If you are greater than 0.5, let's say 0.8, so you can see the fillet become very, very sharp. Okay. If I tick OK, so this is in 3D. This is for 0.8 row value of conic radius. And if I choosing back to 0.2, it look this way. A little bit flat. Okay? So this is the difference between the constant size fillet and conic fillet. Okay, which is I show you just now. So if you need to create a very nice fillet, you are advised to use a V value greater than 0.5. It will look better. Okay. So next we have a look on another type of fillet. We call it setback fillet. Basically, setback fillet it is the option to add a corner treatment for a corner vertex point in 3D parts. You can see this picture, which is having a three fillets that connect to the same common corner. We call it vertex. So the three fillets, right, that meet up over this vertex, and for this vertex, the fillet face, right, it can be even looks more softer and better, which is the right hand side picture that has we apply a setback fillet for that. Okay, so how basically it works, right, for setback fillets? You there's 3 edges you need to select. Okay, 3 edges need to select. Then after that, you tell the system to select the common vertex, which is show it over here. Then you apply the value for the vertex, and you apply a setback fillet over there. Okay, and for the 3 edges that you apply the fillet, right, it can be have different radius value that you're allowed to control. That is using the multiple radius fillet. Let's have a look how it works. So this is a square box. So I'm going to apply a fillet for 3 edges. 1, 2, 3. Okay. Okay, this is without setback fillet. Then when I tick OK, it will look in this way. Pretty good, but you can make it even look better. So How does it work? We apply the 3 edges again. Then setback parameter. Okay, we choose the vertex over here. Then it will ask you how much is the setback value that you want. So now I would like to make one of the fillet become larger value. So I use a multiple radius fillet. And then, okay, you can see the call out. You can change the value directly over here. So I make the vertical fillet, make it 1 mm. So it becomes this way. And the setback value, you can always change. It can be locally, it can be globally. Let me change it to example 0.8. So you see how it works, or it become lesser. You see how it works. Let me make it 0.5. Okay, so when I think OK, it become like this. So you may have a question that why the surface look in this way? A lot of different patch areas, and you don't wish to see like this. So it can be resolved by using an advanced function called delete face. So we use a delete face, and then we remove all the surface that we don't want, the patch areas. We select every one of it, and then we use delete and fill, and make sure you on the tangent fill, so that the surface that you're going to fill in later, you'll be tangent to all the neighbor surface, okay, meaning all the 3 fillets. So delete face is the option that you can delete the face surface and then you fill it back. When I think OK, so the system will working on it to remove the surface, everything, and then it will fill back. Okay? So it looks like this. Very much better. Alright. So what is the next type of fillet that we have? Keep edge end versus keep surface. Okay, as I told you just now that fillet always need to find a place to end. So for example, this example. Okay, we're going to make a very huge fillet for the corner. So the fillet that you make will be covered until the hole. Okay. So because it is need a face to end, so it can be have 2 options for you to adjust the face. Either you want to keep the edge of the circular hole, let it become this way, so that the circular hole, the edge geometry is not changing. So the fillet will become this way. Or you want to keep the surface of the fillet shape, meaning you want to have a constant shape of fillet. Then you will change the geometry of the hole so that it allows the surface of the fillet to extend. You can play around the option when you have this such of situation that your fillet is very huge until you will over cover until a hole in this way. So in 3D it look like this. Okay, this is a fillet. So you see the value is very huge, it's 1 inch. So if you see in visualize, you can see that the fillet actually it is cover, I should say, more than the region that the hole will cover. Okay, extend until the hole like that. So you can play around the fillet option. Either you want to use keep edge or keep surface. Okay. So next thing will be this round corners. Basically, it is another fillet option. Okay, it is same like when you apply a constant size radius. Okay, that you're going to apply for a square shape of box that apply over here. So definitely you will see a sharp corners. So if we think about the perspective of manufacturing purpose, the sharp corner, which is something that we always need to avoid, because not 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 an easy job to manufacture in this way. So you can make a round fillets for that area so that it looks better in this way and then more easy to manufacture because you have a smoother transition between the fillets and the edges. Okay, so next will be variable size fillets, which is one of the command and function that I really like to use, that you can have different value of the fillets along the edge that you apply the fillets. You can change, you can set it at a different quadrant point or different fillet points. Okay, then you can apply the value that you want. Okay, so let's see how it works in variable fillets. Okay, this is the box, the block. So I'm going to apply a fillet over here. And this time I choose the fillet types, variable size fillet. So you can see that every single edge that I selected automatically will come out a few points. Okay, the first point and the end point, and then in between they has different points that you can change the value. For this case, I'm going to change the first one and the last one. For the first one, I would like to make it 1. The last value, I'll make it 0.5. Okay, same for the opposite edge. Okay, start point make it 1. The end point make it 0.5. So you see, it come out fillet in this way. So if you wish to make the center of the fillet even more smaller, you click on the edge, then come out the point. Click on the point, that it will show you the percentage, meaning the location of that point for the whole line, whole edge. So it is at the middle of this circular edge. So I make it even smaller, 0.25. Okay, so when I click OK, I get my fillet with variable size. Okay, so it's a really easy to use command, save you a lot of design times. So when we come to variable fillets, they're actually having an option for you to control the transition for the variable fillets. Okay, the transition types, basically we have 2 types: smooth transition or straight transition. Okay, look at this picture. There's two pictures, the left and the right. They are both also is a variable fillet videos. Okay, from small to big. So you can see that for the left-hand picture, it is using smooth transition, and the right-hand picture is using straight transition. So what is the major difference here is that for the smooth transition radius, right, it will always end the end, right? The end of the fillet will always normal to the base, normal to the adjacent base, meaning that you can see here, you can see that sorry, here the start end and the end of fillet, it is normal to the base of the adjacent base, but then straight transition is not. It's not considered that. Okay, what I mean, if you see in 3D, okay, okay, so for the left hand is a smooth transition, normal to the adjacent base, meaning that you can see that here it is perpendicular to this face. Same for the end. The end also perpendicular, the vector is perpendicular to this face. Whereas straight transition is not. So this is the major difference here for the option. Okay? Let me go back to my slide. So the next type of fillet that we have here, face fillets. Face fillet is a very good command that you can apply the fillet to two faces that even they are not connected to each other. It is using constant size command. Okay, when you key in the radius value. Okay, and then you apply to the two faces that you can see in the picture, the blue one and the pink one. Even though they do not share a common edge, but you still can create a fillet like that. Okay, so if you see the sample, okay, now I'm going to apply a fillet for here. It's a round fillet. So how we're going to do that? We can use face fillet. Okay, this option. So you can see a toolbox. First face, second face. Okay, and then the value we can control over here. Let's make it 1, 2.5. It create a round fillets like this. Okay, so this is how face fillet works. Not only that, actually, face fillet is a very good function that you can remove many silver face, and it can be a bridge between two face. So the next type of fillet is face fillet. Okay, also the same, but the difference is that there is another option when you control face fillet is that you can have constant width face fillet. Okay, what it means by constant width. Okay, look at the picture. If you apply this option constant width, right, the fillet will stay the same size along the face, 3D face like this. If you're not using that, right, you can see that the fillet actually changing its geometry. Okay, especially the corner. You can see that it actually visualize. If you visually look at it, it is different. It is small and then until bigger value. But if you apply a constant width, right, it is always the same size. Okay, let's see how we'll do that when using face fillet. So I have two blocks here, which is exactly the same. So also using face fillet. Let's look at the first example, the left hand. So I'm using okay, I apply the edge over there. So it is not apply any constant width option. Okay. But if let's say now I'm using this face, okay, it is using a face fillet. You can see I selected two face, and then I have the option. We call it cut width, which is a system control the vector for the cut width that you can see on the screen, the picture. So it is always the same size along the whole edges. Okay, only face fillet can do this. The first example is a constant size fillet that do not have that option. That can allow you to control the cut width. That's why, although you are keying 0.75, the same value, but it's still different because remember, fillet need the face to end. So SolidWorks will extend the geometry and change the size of the geometry of the face to fulfill your input or input setting. Okay, so the next type of fillet that we're going to share today, which is full round fillets. So it looks like there is sometimes to regenerate the screen. Alright, there we go. Full round fillets. Okay, basically, when we apply full round fillets, it is useful for when we want to creating a rounding of geometry. We don't need to key in the value of the radius that you want. It is based on the geometry that you selected. And the fillet will automatically apply to the three faces that you select. Let's see how it works. Okay, now I'm going to apply a fillet, full round fillet, rounding up geometry for this surface. Okay, so I click on the fillet. So the last type of fillet you can see over here, full round fillet. So 3 boxes. No need to key in value for the radius. One face, next face, third face. So you can see that that is a fillet come out already. Okay, it is really I also like this command a lot, because let's imagine if you don't have this command, how you're going to actually create this such of geometry. Alright, so that will be full round fillet. So basically that's all for fillet property manager, meaning the types of fillet that we have, the standard 4 types of fillet. Just a short recap. Constant size fillet, and then constant size also you can apply a conic value or circular value, and then the next one will be the face fillets. That's like 2 faces. Then next will be variable size fillet that you can have different radius value along the edge that you select, and then the last one will be full round fillets. So after we understand that how fillet works and then the type of fillet that we have, so why we still having errors when we apply fillets? I believe that these 2 types of fillet these 2 types of errors that you very often to see it when you apply a value to your 3D parts, you apply a fillet, but it failed. Okay, so why does a fillet fail? Basically, it can have 2 major reasons that why a fillet will fail. First one is because the software is unable to extend the faces along the path, so that to giving a fillet to have somewhere to end. The secondly is that the value that you enter, your input is too large for the geometry, so it failed to create the fillet. 2 types of it, 2 reasons. So that is the reason. So now I'm going to share with you some of the different techniques to how to handle tricky fillets. Even though we know the function, we know the concept, but how do we handle this sort of geometry, which is very tricky. I'm going to share with you a few techniques. Alright, first one. This is a simple example. Okay, what we're going to do is apply a 0.25 inch fillet along the highlighted edge blue that you can see. Okay, but definitely when you go to add fillet, right, you will fail. It will fail. And why? Let's we have a look. Okay. Okay, let me open the file. Okay, this is the 3D part that we're going to apply a fillet. Okay, so we can see that the first fillet we apply here is this one. The value is 0.25 inch. Okay, then we apply the next fillet. Over here, the value is 0.22, and we apply the third fillet. Is larger, is 0.38. Okay, so next we're going to apply a 0.25 fillet over here. Okay, 0.25, enter. So when we click OK, here you go. The radius of the fillet is too large, but yeah, it is the error that I mentioned just now, and we always see it. So it mentioned that the value is too big. So is it that we should adjust it smaller? How about 0.24? No, it is not working. 23 to 2. Oh, right. So 0.22 we can create the fillets. Look like this. But the important thing is that it's not the thing that we want. Based on the requirement of the design, we always receive, we know that we need to have 0.25 over there. So how are we going to do? Okay? So you can see the first step we're going to do, right? We need to identify the potential fill points. Look at this picture, which is just now you see that in the 3D, the most likely the failing point, right, actually is the corner points of this corner that you can see we highlighted in red color circles. This is the most likely the failing corner because SolidWorks unable to extend the 0.25 fillet to this corner due to the very complicated geometry. So what we're going to do, right? We know that that is the failing point over there, so we should remove the failing point. So just make a simple cut away. Actual cut the red color region, cut it. Okay? And then we apply the 0.25 fillets that you can see on the screen. It is able to do that. And lastly, for the cut away, right, we fill it back using the delete face option that I mentioned just now, delete and fill. Then you will fill back the corner. And then we get the result that we want. Okay, let's see it in action, how actually that is works. Okay, so this is the first cutout I make. Simply a 2D sketching. Okay, then I sketch in this way. Then I make a cut, extra cut to here. Okay, then apply the fillet 0.25. So it is successfully built a fillet now. So this cutout area, I need to remove it. So I'm using a delete face option to select the 3 faces, and then I use a tangent fill to fill it back. So we got this. It looks very much nicer in this way. Okay, so this is one of the technique how we solve a simple problem in like this. A little bit tricky. Alright. Or actually you can have an alternative solution. So what I teach you is we identify the filling point, we cut away the filling point, and then we create the fillet that we want, and we repair the corner. So, or there is another option is that you rearrange your fillet orders. Fillet orders is very, very important. Meaning you are encouraged to complete the fillet by in sequence. What meanings by sequence? Okay, I show you another example. Exactly the same model, but we arrange nicely the fillet order. Okay, so you can see the first fillet that we create is the large fillet. So you are advised that to create the fillet in this way, meaning you create the fillet for the larger value first. So and then we put in this is 0.38, 0.225, then another 0.25, then the last one is the smallest value, 0.22. So you can see that we do not need to have any repair or identify the failure area and then repair it and then correct it. It can be done. Okay. So you can use this ways also. So for the patch area, you just need to delete and fill. Then it will look better. Okay, so this is how another alternative solution to solve this geometry problem. Okay, so this is the second example that how do we avoid the fillet errors. Okay, so you can see here 2 pictures, tangent propagation on and tangent propagation off. So what is meaning that and I'm not sure about what is the SolidWorks background is working on it. sometimes turning off tangent propagation can help you to solve the problem. Look at the left-hand picture that we apply a fillet over the blue edge. It is failed. It is failed because with the tangent propagation on, right, it cannot be created. But sometimes when you off it, it can successfully create it. Okay, so how does it work? Okay, this is the geometry that I'm going to apply a fillet on this edge. So I click on the edge. Okay, again you can see that it is failed. Okay, again it come out error. But if let's say tangent propagation over here, I off it and I select the two edges manually. Now you can create a fillet. Okay, sometimes it's to help. Okay, you are recommend sometimes you can off it and try this workaround. But the thing you need to know that is that if without the tangent propagation, right, all the edges you need to select manually one by one. All right. Okay, we look at the third model, which is using face fillet to solve the problem. Okay, look at this small picture that you can see the green color and yellow color face. These are all the so-called small silver surface that near to the corner. Basically, a standard fillet cannot work. Why that? Why we say that? Okay, let me show you. Why I say that? Let me show you. Okay, this is the first corner that has a small face over there. A big face, and a small face. But the thing is, I want to make a corner fillet over here. Same for this one. Big face, and then two small face. Okay, let's see how we going to apply fillet. Let's say now I want to apply a fillet over here, and I key in 10 mm. Okay, you can see that the fillet automatically end over these edges. This is because SolidWorks will automatically find the face to end. So you see, no matter how I change the value, 5 mm, 15 mm, 30 mm, oh sorry, it's too big, 20 mm, 12 mm, you can see that the surface is always end there, end on the edges of the green color face. Okay, so what we can say that is that the constant size fillet that applied on edges, it cannot be worked. So to solve this such of a small silver surface area problem, right, you are advised to use face fillet. Okay, so the way to work, select the first face, select the second face. So you can see that SolidWorks now able to create the fillet with the 10 mm, and then it will skip the green and the yellow area, the silver surface, and you can successfully create the fillet. Okay, it's really very convenient and it saves a lot of your time to do repair, delete base, fill in, and to create the geometry that you want. All right. This is how we use the face fillet to solve those silver surface area that close to the corner. Okay, same for this example. Also, we're using face fillet to be a bridge. Okay, to be a bridge to connect between the blue face and the pink color face. You can see it in the right hand side picture. So when we apply face fillet for the blue and the pink face, you can create a fillet like that. But if you see on the left hand picture and you're using a standard constant size fillet, right, it will fail. Okay, this also can be applied. Okay, now I show you another example that even more tricky. Okay, have a look on this geometry. Okay, let me show you directly in 3D. Okay, what we want to do is that basically this part, right, it is divided into two bodies. It has two bodies. Okay, this is the top bodies. This is okay, let me show. One moment. Okay, this is the top bodies in blue, and then this is the bottom body. Okay, so this is actually the butting line. So the face that connect between the two bodies, right, is the butting line, meaning that this is a butting line. Okay, you can see over here, butting line. Okay, so now, right, for the bottom bodies, I have actually created a fillet in blue. And now I'm going to create another fillet that connect exactly the same size with this fillet, but it is variable size, which is we want a result like this. Okay, it is connected to the bottom fillet, and then it becomes larger and larger. So you may say that, oh, we can directly use a variable size of fillet. Okay, let's see how it works. Variable size fillet, connect this one. Okay, for start point, I key in 0.25. That's same as the bottom. And the top, I key 1.5. Okay, but the thing is, you see, okay, they're actually not exactly connected. There is an extra volume of fillet come out, and the endpoint is not connected. You see that this edge and this edge, they are not coincident, not matching. Same for this one. Okay, they are not matching. But I need it to be exactly same. So which means that variable fillet is not working. Okay, so how can we solve this type of problem that it will taking a lot of manual job? So the first thing is that I will create a split line, okay, which is this one. I draw a line, which is 1.5, the radius value I want, over here, this corner. Then I'm using split line option, okay, to split the surface into two areas, 1, 2 area, okay. Then next, I create another split line, which is here, this one, to connect the line exactly touching with the bottom fillet edge, the corner, the end point of the edge, and then connect to the first split line that I create. So it become connected. So same for the split line 3, another side, to draw a straight line to connect the end point of the top fillet and then the end point of the bottom fillet. Lastly, the fillet is a round shape, so at the bottom, I need to create another split line that exactly same with the fillet size. So after that, I use delete face option to remove all the extra faces so that here now it become a open area. Okay, so now this geometry, right, it become a surface body. Okay, you can see there's a surface body over here, and the bottom is a solid body. Okay, so now we need to going to fill back this open area and then form a solid again. So we can make use of boundary surface option. Okay, how it works, basically select the one pages, meaning left project to right, and then the top project to bottom. So each of the edges that you select, you can have different options for you to choose the relation. It's like the new boundary surface that you created, what type of relation you want to create between the purple color faces. If you want to have tangent, then you can choose tangency. If you don't want anything, just contact only, you choose none. So when you create OK, you generate a surface like this. So meaning this new boundary surface, right? Your tangent to this face and tangent to this face, they are tangent. So the top and bottom only contact. So you can create a smooth transition. Okay, so after we created the surface, lastly is that we need to combine all the surface as one and then create solid, form of solid bodies. So now you have two bodies, solid bodies, one top, one bottom. And lastly, we combine them as one solid body, just using combine by features and then using add, combine them together as one. So you see, we solved the problem, and now the edges, it is connected and there is no extra volume, exactly 100% match. So this is how we solve the fillet problem using another technique. More manual job, there are lots of split line involved, delete the extra face, fill in back, connect, knit the surface, combine as one, and then form a solid body. Alright? Okay. Next example. It is another simple example. Actually, you can see that in the picture, the left and the right picture is the different. Okay, actually it's slightly different. If you notice that, you can see at the left hand side the picture, the fillet that created, right, actually it create a very sharp corner of fillet. Okay, let me show you in 3D. It is more easy to explain. Okay. Yeah, so this is what I mean. You can see the sequence we create the fillet. This one, the big one. Okay, then next. So you can see that the red color faces is the so-called sharp corner faces. Okay, that you can see in the PowerPoint just now, which is actually the left-hand side picture is the same. There is a sharp corner over there. So how are we going to resolve this problem? Because we don't want to see this sort of fillet. It's very difficult to manufacture. So we can do it this way. We can using split line again. Okay, if you can see, I draw a line over there, a line. So we split the surface like this, become a square shape. Okay, if you see from the left hand side, square shape, alright. And then I split another surface like this, another square shape. Okay, so that it is symmetrically same. Then I delete and fill. Okay, so you get the fillets I want. It's not sharp corner, so it looks pretty. It look better now, right? No more sharp corner. So why make it different for this type of these two type of fillet ways? Okay, you can see from the next picture. Okay, this is the first type of fillet that I shared just now, the so-called sharp corner. If you look at this zebra stripe, right, you can look at the fillet. It is like the tangency control is not so good, and you can see that the color distribution is not even. But if you look at the next picture, that we repair the fillet using split line, and then we're using delete and fill to create a better fillet, more symmetry. Then you can see that the distribution is even now. It is symmetry, and then it is look even much better for the tangency control. So this is another standard problem that we will face it when we do fillet. We always have sharp corner fillet, and then how we're going to solve it. All right. So this is the Another example that I'm going to show today, which is a convex to concave fillets. What's the meaning? Convex to concave. Okay, look at this picture. You can see that in the arrow, you can see that there are few area is convex fillets. Okay, convex meaning it is it is fluid this way. The fillets, okay, the vector is pointing out. Okay, but you can see this region is concave. The vector is pointing in. So when there are two different directions of the vector, right? When we do fillet, it becomes very challenging. So in 3D, how we going to do that? It is even more complicated. With this one. Okay. All right. So again, this part is actually has two bodies. One body, two body. So the step to do, first thing, we apply a fillet over here. This is the first fillet we apply. This is convex fillet. Okay. Next fillet we apply is over here. Another convex fillet. Okay. After we apply that two fillet, right, we combine the bodies, become as one now. You combine them, become as one. Then now, which is we're going to focus on this region. Okay, we're going to focus on this region so that we want to connect the big fillet, the big convex fillet, to the small convex fillet. Okay, but there is concave area to involve. So you can see that here is a concave area. Okay, so what we're going to do, we create the first split line, which is this line. Okay, we create that. You can use spline to do that, to sketch a line so that it is connect to this edge, tangent to this edge, and then tangent to this edge. Okay, then we create second split line, which is here and here. Then another split line. This split line is to connect the fillet edge to this fillet edge. Okay, then we delete extra faces. Okay, you see that? So this is the concave area, and this is the convex area. So for this open area, right, we just need to use surface filling option in surface fill. Then we select all the edges, okay, and then you can set the relation between the edge, the new fill surface, and the adjacent face. What type of relation you want? There's contact, there's tangent, there's curvature. So you can see that some of the edges we make it tangent, especially with the fillet, we should always make it tangent. Some of the area you can make it contact. So finally, you get this surface. Okay, definitely. Here is tangent. These two, that should be tangent. Okay, and then here, this one and this one, there should be tangent as well. Okay, then but on the top surface and the fillet, you can make it contact. So you get this result. So how do we check whether the fillet created is tangent or contact or whatever? You can make use of the zebra stripes option in SolidWorks. So by clicking on this, right, you can look at the stripes, how it flow over the geometry, that you can check tangency. If you see the black color stripe, they are continuous, meaning you are tangent. If the black and white is not continuous, can see on the this bottom, these two faces. Okay, you can see this one and this one, right? You can see the black is not correspond to the black. So if you see this such of combination, right, it is only contact. So obviously the new surface, the big surface that you created, right, it is tangent to the fillet because the black stripe and the black stripe is continuous. Okay. Okay, due to time constraint, I'm going to show you that will be actually a lot of different way to solve the problem. And I will skip these two. Okay, I will skip these two. This one and this one, I'm going to skip it. If you're interested to know that, you are welcome to always contact me how to solve these two geometry. I'm going to show you the last one, which is, I think, the best example that I'm going to show you today. Okay, it's a bottle, consumer product. So this is most what we can say is the most difficult types of fillet we're going to do. Why? Because you can see, if you see all the edges that we highlighted, the fillet is going to end to no way. Okay, there is no way to end. It is like starting the fillet until the end, right? And then it become nothing. There is no face can extend, no face can end, no face can change the geometry. So the only chance here, right, we can create this such of fillet, right, is to generate a sweep surface and then to make that fillet. Okay, let me show you in action how it's going to work. Okay, this is a fish bottle. I believe you always see this in supermarket. Okay, so the first thing we want to do is, I mentioned just now, the blue color is a sweep surface. We just draw a circle. Okay, this is a circle, and then we sweep it along the edges until the end. But you'll notice that the end of the sweep surface, right, is not long enough. So what we need to do is that we need to extend the surface, and then we trim it. So how I trim is that I create a roof surface over here. Okay, I extend the edges. This is the edge, the trim edge. So I create a surface that perpendicular to the trim edge. Okay, then I use that orange surface to trim away the sweep surface, like this. Okay, so when the sweep surface is done, right, so I further trim away again with the bleach bottle. Okay, then you will see this. So here now, it become open area along the edges until the end. So to close the area, we need to create multiple boundary surface to close it up. It cannot be created in one shot because we need to maintain the tangency and okay. And you can see that the surface is like the edge is one by one. So sometimes it is not allowed you to create the boundary surface in one shot, and you can create multiple surface to fill in. So you can see we create one by one. Start with the green one, then we create the yellow one, another, this is orange, then continue, we fill in the area, the purple color, we fill in, then we fill in the blue area, and lastly we fill in the light blue area. So we created the fillet like this, right? So we're done. So this is how we going to handle very difficult fillets like this. Looks good, right? Okay, done. So that will be the end of the webinar today. If you have any question, regarding the fillet, or you wish to obtain the sample files from me, you can always call me and contact me with my email and my phone number. All right, and thank you everyone, and stay tuned for our next upcoming webinar, and you can always browse to our website. Thanks, and see you again. Bye.